Hi folks, Nick from FrogLogic here. Thanks for joining my talk all about cross-collaborative QA, a behavior-driven look at the DevDev relationship. I want to start by telling you a story about alcohol, fried food, and alternative energy. The summer after I got my bachelor's, I worked at a biodiesel chemical plant. Biodiesel is made from reacting used cooking oil with an alcohol, like methanol, and a catalyst, like sodium hydroxide. That's what we did every day. And just like many software product teams do, we at the biodiesel plant ran very lean. There was really only one person for each business function. Now, I'll discuss an interaction between two employees from that summer. The first one being myself, and the second, our head of business development, Dan. I'll start by talking about our backgrounds. I had just spent 4 years studying chemical engineering, while Dan had many years' experience managing and growing businesses. About a week into working there, I decided I would run some experiments to tinkle with the biodiesel recipes. 2 weeks of tinkering went by, and I presented my findings to the team in the form of complicated, twisted spreadsheets, long chemical formulas, lots of unit conversion tables, talk of molar masses and Avogadro's number. It left Dan to panic. I basically tried to tell him that we were going to change X, Y, and Z, and that A, B, and C were going to happen, but I did it through equations. My goals were to optimize our biodiesel production, using as few chemical reagents as possible to yield as much fuel as possible. Dan's goals were focused on attracting customers to our finished product, and of course, the business's bottom line. But we did share the same vision though, and it was this: make good, cost-effective biodiesel. We were on the same page, but that page had text written in languages we couldn't speak to each other. The point of this story is to say that in what we call cross-collaborative teams, for example, ones with technical types like chemical engineers and non-technical types like business developers, there needs to be a ubiquitous language set in a framework that everyone can understand, a framework which prevents miscommunications and misunderstandings of requirements across roles. Let's extend my relationship with Dan to the designer-developer relationship in the context of software product development. Is there a framework that exists to give us a shared understanding of product goals, all the way from early conceptual talks and user stories down to the QA stages of development and testing? There absolutely is. It's called Behavior-Driven Development, or BDD. Some folks here might know BDD, or Behavior-Driven Development, in the context of automated software testing. Here we'll look at how it can be used as a tool for collaboration across roles. Before we dive into what BDD is and how it helps improve the DevDev relationship, let's consider a second sort of contrived app scenario similar to my mishaps with biodiesel concoctions. Your group is working on an online banking app. The product manager says that the person using the app will first need to have an account. The developer thinks, okay, I can create a user login form, and they implement the login feature. But let's back up a second. The product manager comes from the world of banking. To them, an account literally means a bank account, not a login account with user credentials. Behavior-driven development, or BDD, is an approach to engineering software which inherently encourages collaboration between different roles in a project, even across teams, what we like to call cross-collaboration. This conference is about designers and developers, but really the BDD paradigm involves designers, developers, product managers, business analysts, QA analysts, basically the whole product group. The idea is that from concept all the way to testing, encourage conversation and use examples to create a common understanding between all stakeholders of how the software should work for the user. And that's the key: all stakeholders are involved in the conversation. Why is this important? Cross-collaborative teams have many unique and defining features. By the very nature of a diversity of roles and backgrounds, new opportunities for innovation, creativity, and fresh perspective are available. Now, I hate to stereotype developers or designers or QA engineers or anyone else, but just like during that summer of getting dirty at a biodiesel manufacturing plant, folks with different career experiences and trainings in different business spheres approach problems under their own lens. When you bring folks together with different backgrounds, you get different approaches to the same tasks. And in software, that task is often making the user happy and successful. Okay, so we have a conceptual foundation for behavior-driven development. Now let's get into the nitty-gritty of how it works in practice. BDD works by defining a common specification for all stakeholders. It focuses on describing the desired behavior of an application instead of the implementation. Think what, not how. And so that everyone is on the same page, BDD files are written in accessible, domain-specific language using natural language constructs. In our tools, we use Gherkin, a quasi-standard for expressing the desired behavior. Gherkin has some core, what they call keywords to describe software functionality. In the Gherkin format, software functionality is described in terms of features. Each feature is then described via use cases or scenarios. Finally, each scenario is expressed as a sequence of interaction steps, typically grouped in a given, when, then structure. Now, during this talk, we'll use a sample Qt application for the following BDD examples and demos. The app is called the address book, and it's a simple application used for adding contact cards to a standard address book. Let's write out a sample BDD feature file. We'll start with a typical user story. As a user, I want to fill the address book with entries. The BDD feature file follows. First, the feature, filling of the address book. The scenario statement, state after adding one contact entry. And then the given, when, then interaction steps. Given address book application is running, when I create a new address book, and I add a new person with the following details, then one entry should be present. Notice here we're focusing on what is done and not how it's done. And the Gherkin language supports focusing on the what. There are no scripting language features like loops or conditionals. The syntax is bare bones, and really it reads like plain English or Finnish. Logic is separated from the implementation. Now, although BDD is principally an idea about how software development should be managed by both businesses or business interests and technical insight, the practice of BDD does assume the use of specialized software tools to support the development process. The Squish GUI tester from us at FrogLogic features first-class support for behavior-driven GUI test automation projects. We talked about how to use Squish and BDD for GUI test automation of Qt applications, especially in cross-collaborative teams during the last Qt World Summit. And I want to offer a similar demo here in this conference for new folks joining. First, a little bit about who and what Squish is. Squish is a cross-platform tool for functional GUI testing, which acts upon the application's GUI layer. Through a special product edition that we have called Squish for Qt, it has dedicated support for the Qt framework, including widgets and QML. These applications can be running on embedded, mobile, or desktop platforms. With Squish, you have built-in support for behavior-driven development and testing, which we'll see in a moment. And Squish is used worldwide by thousands of companies in diverse industry settings. We're used at small startups, large corporations, and everyone in between. So let's take a look at the Squish Integrated Development Environment, or the Squish IDE. So what I've done is set my AUT, or application under test, as that sample Qt address book application within my test suite settings. In here, you can see I have a test case with the same BDD feature file steps that we designed earlier. You'll notice warning symbols next to the given, when, then interaction keywords. That's a signal to the test developer that that step has not been implemented. But good thing for us, Squish has an excellent recording feature where we can record our missing step implementations. So let's do that. I'll go ahead and press record. In the Squish control bar, we see our step highlighted, given the address book is running. Squish automatically launches our AUT, so we can click next right away on that step. The next step requires us to create a new address book. We'll click the new button. Then we want to add a new contact with that person's information. Now it asks us to verify in some way that one entry is present. Here under the insert dialog, there's a number of verification types. We can verify a UI object property, take a screenshot, verify tables, or even do complex visual verifications. You can also do image searches or verify on-screen text with the Tesseract OCR engine. We'll verify with a screenshot. We see that control returns to the IDE where we can choose from the object tree. I think it's simpler just to use the picker tool to visually select the area of the application we want to capture. So we'll click the pipette icon and choose Save and Insert Verification. Finally, click Next to finish. Now let's play back what we just did. Notice that it's probably too fast for most folks to see even what happened. Returning back to the IDE, we can see in the test results view that the steps which passed, including verifications, and you can expand these to view details where included. Note that in the case of failed verifications, we'd have more information available to us to diagnose the problem. For example, in the case of a failed screenshot verification, Squish has capabilities to toggle between actual and expected screenshots. Now let's take a look at what might be interesting for the developer, which is the backend implementation file. Here we see a Python script where each of our gherkin keywords serves as a function decorator for the following step function. Within the step function, we see calls to the Squish API, which act as tools to exercise our AUT. Of course, we need to identify our UI object somehow, and Squish does that through what we call an object map, also called an object repository. Each object name set in the Qt application is stored in the object map along with a set of properties that uniquely defines the object. And this is important because we're identifying controls based on their properties and not something more high level or superficial like an image of an object. Switching back to the feature file, Squish will from now on recognize these step statements in future test cases within our test suite. So you don't need to re-record for every step you already have in place in your implementation file. I'll show you just one last thing here, which is a slightly more complex feature file. Same application, but we see here we have multiple different scenarios in our feature file. And if we take a look at this scenario here, when we add multiple entries in one shot, we're actually able to parameterize our BDD file. And that's done through a simple loop in our implementation file. So where do we go from here? Well, this feature file has a lot of uses. First, it can be used as input for planning and in the UI UX design stages. A good friend of mine, Maya Reinhardt, a Boston-based product and UX designer, shares a similar nonlinear background into product development like I do. Her training is in civil engineering. And I bring her up because she wrote a really great article that I'd like to reference here. And this article does a perfect job of covering the design thinking process, which our designers will be familiar with in terms of what engineers are familiar with, the scientific method. The scientific method contains a series of somewhat rigid steps for answering a scientific problem. They are defining the purpose or question, research, forming an hypothesis, designing and conducting the experiment, data analysis, drawing conclusions, and of course, repeating if necessary. Now in Maya's article, she anchors the 7 steps to design thinking, and I want to augment her kind of novel and a little bit looser interpretation of the scientific method for design thinking with behavior-driven development, highlighting a couple of the steps in that scientific method where I think it can be used. So the first, defining the purpose or question. Maya likens this step to design thinking by saying a clear directive should be defined which aligns the entire team on the problem you're trying to solve. And this entire team includes designers, developers, QA, and product management. Now, I don't think I need to repeat myself here. We've already seen that BDD by nature is about getting everyone on board speaking the same language so that everyone has total visibility into the project. The second, research, it's about the who, what, when, where, why, and how of user and product research. In terms of behavior-driven development, we can liken this to a kind of Three Amigos session folks are probably familiar with. As for the experiment stage, this could be, for example, an internal or external design review. In a BDD sense, UX works together with dev to generate a clearer understanding of what needs to be implemented and also what's technically feasible from the get-go. Drawing conclusions. Here it's about drawing out what new patterns came out of the experiment. It's also a step for documentation, and in Maya's interpretation is the last step before the des-dev handoff. I'll talk more about how BDD feature files can be used effectively for documentation later on. And the last step, repeat. The design thinking process is iterative, just like the agile practice of behavior-driven development. So what about dev and QA? How can development and QA use this feature file? We can see that UX designers and developers work together to create a better understanding of what needs to be implemented and the technical challenges for the UX implementation requirements with BDD. What happens when we do this? Well, this part is and should be done before any line of code is written. When it comes time to write code, let's remember that BDD feature files derive from a characteristic user story. This means that development down the line and from the get-go is based on users' needs. This reduces development workload and will also make the product manager, business manager, and most importantly, the user happy. This next stuff is likely more for the QA-centric engineer. Remember we talked about abstracting away the implementation? In BDD, the logic is separated from the implementation. The result of this is that you benefit from automatic modularization. Traditional script-based test cases require a lot of careful consideration and discipline to avoid that they grow into these huge monoliths of script code which are hard to maintain or even extend and reuse. It's very easy to accumulate technical debt, and avoiding this problem requires employing professional software engineering practices. Behavior-driven development, when used for GUI test development, helps a lot with this. Instead of working with one contiguous block of script code, a Gherkin document decomposes a complex test procedure into smaller steps. Equally important, each step is defined by its semantics. Instead of describing how something is done, like click the create button, a step explains what is done, create the user account. Gherkin documents are also executable documentation. They accompany the entire project development process. And when you use BDD all the way for test development, the test reports are no exception. When doing behavior-driven testing, you'll often include one or more verifications in your BDD steps, like verifying UI objects properties, which we did earlier in our demo with the screenshot verification. By associating the original Gherkin description of the desired behavior with the final test report, each verification is associated with the step which was executed at the time the verification was done. This means that in addition to documenting how something was verified, the test reports also document what was verified. What's more is that the structure of the BDD specification is retained. Each BDD test case is structured hierarchically, with the feature being tested at the topmost level and different scenarios in which the feature is exercised at the secondmost level. Therefore, when you browse through test reports, you don't have to face a huge sequential list of verifications, but instead you can gradually drill down, viewing the test reports on different levels of granularity. We actually have another tool that we offer called Test Center, which manages all of these test reports with special treatment for the drilling down aspects of BDD test results. Finally, improved processes from conception to testing at the end result in better quality. BDD minimizes maintenance efforts, reduces the number of bugs, lowers costs, and results in high quality, well-tested products, with the user's needs kept in mind from the start. If you're looking for BDD tutorials, tips, and training, visit bdd.tips. And if you're interested in Squish, have a look at our website, froglogic.com/squish. From there, you can get a free evaluation copy of the tool, which comes fully featured, fully supported, with industry-recognized tech support. And for the latest in company and product news, blogs, announcements, and where to find us, follow us on your preferred social network. I really hope you enjoyed this talk. Thanks.